Yes, sir.
In last class, we have discussed what is Newton's second law and the numericals. We have solved around 7 numericals, which is representing the Newton's second law of motion. Is it yes or no?
Yes,
Yes.
sir.
In today's class, we are going to study the next concept is called as Newton's third law of motion. What we are going to study? Newton's third law of motion.
Newton's
Newton's
third law of
third law of
motion.
motion.
Newton's law of motion. This is the last law of Newton's which has been given to represent the motion of a bodies. So let us comes to here. What is happening here in this Newton's third law means in the sense of in this picture you may observe carefully something is happening. What is that? Can you able to explain all of you?
Force is acting.
Huh? What is happening? So the person he is wearing something. A boy, the boy who is standing, understand in this picture you may observe, he is not standing normally. He is wearing something. Roller skates. Do you understand? He is wearing the roller skates. Have you observed?
Yes, sir.
Please tell me. You may observe in this picture. He is wearing what?
Roller skates.
Roller skates. Is it yes or no? Skating, right? So he is wearing roller skates. Now, in this picture, what are you trying to observe? He is trying to push the wall. Is it yes or no? With his hands, he is trying to push the wall. Is it like this, correct or not?
Yes, sir.
All of you observe very carefully. With his hands, he is trying to push the wall. Means he is applying the force on wall. Is it yes or no?
Yes, sir.
But in the second picture, if you will observe, if he will try to push this wall in this forward direction, he is used to move which direction?
Backward direction.
Backward direction. You may see here, once he's trying to push the wall in forward direction, then he came backward. Means in the sense of the wall is also exerting force on this boy. Is it yes or no?
Yes, sir.
But the boy is alone moving, wall is not moving. Why? Because wall is a constant object and it is having more mass. Is it yes or no?
Yes, sir.
Yes, sir.
Yes. But here a boy comparatively the mass of the boy is less, so that even though he is exerting the same force on this wall, the wall is not displacing, but the boy is displacing. That is what we used to call as Newton's third law of motion. What, sir? You are saying some example, a boy is trying to push the wall with the help of roller skaters and he is trying to come back. This is what Newton's third law of motion. Not. So observe very carefully all of you in this. So in this picture only we can explain the complete Newton's law of motion. So let us discuss. A boy wearing a roller skates stands facing a wall and push the wall with his hands. Have you noticed in the picture? He's trying
Yes, sir.
to push the wall. He's trying to push his wall who is wearing the roller skates. So now what will happen? You observe. The boy finds himself moving backwards. Is it yes or no? I am trying to push the wall like this, but I am observing that I am finding myself, I am moving backwards, away from the wall. Is it yes or no?
Yes, sir.
So if you observe that, if you are moving away from it, means the sense of somebody is pushing you back, away. Who is that? It appears to be who is that? Somebody is pushing you backwards, so that only you are moving backwards.
Force.
That which force? Who is? Wall. Is it yes or no? So that
Yes, sir.
you will feel that the wall understanding which is existed in front of us also pushes understanding us, so that we will, the boy in this picture, the boy will move away. Or else if I will be there, I also will move away. So what is happening actually here means in the sense of when the boy exert a force on the wall, when a boy exert a force on the wall by pushing it with his hands,
Hands.
Hands.
Trying to push the wall with his hands in a forward direction, then what is happening exactly means, understand, the wall also will exert equal force in the boy. In which direction? The boy is exerting force in forward direction, so that wall is also exerting force in which direction?
Backward direction.
Backward
What
direction.
is that? Opposite direction. Is it yes or no?
Yes, sir.
Opposite direction. And also you observe the boy is wearing the roller skates, so that as we know that the opposite force exerted by the wall make you move backwards. Is it accepted? All of you?
Yes, sir.
Yes.
Yes,
So
sir.
observe here. The boy on
Yes,
this
sir.
roller skates is exerting force on the wall towards to the left side or else the forward side. Understand? So to opposite to that, to resist that reaction, the wall also will exert an equal amount of force on the boy towards to the right side. Understand? He's applying the force in the left side means forward, and the wall is also exerting this equal force in the boy towards the right side. Understand? So due to that only, the boy moves backwards to the right side. Is it yes or no?
Yes,
Is
sir.
it yes or no, all of you? Will you accept it or not? Yes?
Yes,
So that is
sir.
the reason you may observe here. Understanding. So the boy is exerting the force in the forward direction. Understand? Means in a sense of in the direction of towards to the left side. You may observe here. He is trying to apply the force in the left side. So the wall is also exerting the equal amount of force in right side. The wall is also exerting equal amount of force. Understand? Equal amount of force in right side, so that the boy who is wearing the roller skates, he is moving himself, he is finding that he is moving backwards. Is it yes or no?
Yes, sir.
Yes. Suppose you see, suppose let me take now here, Pradosh is standing. Pradosh is pushed, understanding, very slowly, so that he will travel backwards less distance or more distance. And or else, suppose let me take now Tamil Selvan. Tamil Selvan pushed this wall very forcefully, so that that person will travel very long back or very short distance. Very long distance he will travel in backward direction or very short distance. Suppose if I push forcefully, is it I will go more back or else I will push slowly? Is it will go more back? Which case I will go more back?
Sir, when we push more,
When we push, Laksha?
very fastly.
More.
Or else when we apply more amount of force, if I will apply more amount of force, then wall also will exert the same and equal amount of force. Suppose I will exert the 10 Newton force in first, then wall also will exert how much force? If I will apply the 10 Newton force on the wall in the left side, then the wall also will exert same 10
10
Newton force,
Newton.
but in opposite direction. Is it yes or no? Is it yes or
Yes,
no?
sir.
Right.
Yes.
Same way, suppose another person, if I will apply 100 newtons of force on the wall, then what will happen? Wall also will accept same 100
100
Same
newtons.
100 newtons.
the right side. So that is only which to called as. Understand? You can see because of when the person is applying some amount of force in left side, the wall is also exerting same amount of force in opposite direction towards the right side. So that is why the boy is coming backward. Do you understanding? Because he is wearing the roller skate, so that he is moving backwards. Is it yes or no?
Yes, sir.
He's moving backward. You understanding, all of you?
Yes,
So
sir.
from
Yes,
this
sir.
action, you may observe the boy is exerting force on the left side on the wall, and the wall is exerting force on the right side on the boy, so that the boy is moving backward, but there is no change in wall because wall is a very big mass. Is it yes or no?
Yes, sir.
Understanding? Mass is very big, very more, so that no displacement in wall. But we can observe the boy, he is in roller skate, so that he can easily walk. Is it yes or no? He can easily move. Yes or no? Ra?
Yes, sir.
Yes.
What will happen? So now, let us discuss. From this, we can make some conclusion. Can you able to say some conclusion? A boy is exerting pressure on force on left side. Wall is exerting force on right side. But both are in what? Equal and opposite. Is it yes or no?
Yes, sir.
Equal and opposite. Is it yes or no? Ra?
Yes, sir.
From this, we can make some conclusion that from this discussion, we can conclude that when a boy exerts a force on the wall is also exerting what? Equal and opposite force on the boy. Is it yes or no? Ra?
Yes, sir.
So that is only, this is an example of which will illustrates the Newton's law of motion. Are you understanding, Pradosh, Elamukil, Tamil
Yes, sir.
Selvan? So from this, I can make a conclusion that, what conclusion I can make? You tell me. When a boy exerts, conclusion. What is the conclusion, Ra? When a boy exerts, force on a wall, what will happen? Wall also exert same equal amount of force. Equal amount of force on boy in opposite direction. Is it yes or no? That is what most important.
Yes, sir.
Opposite direction. So this is what we are concluding from this given example. So this is only the illustration of Newton's third law of motion. This is, we can say that it is an example of Newton's third law of motion. So by this time you may understand Newton's third law of motion. What is Newton's third law of motion? Can you able to say what is Newton's third law of motion? Manya? Samya?
Every force has equal
Yeah.
reaction.
Force has equal and opposite force. Correct or not? So every action, every force not, every action is equal and opposite reaction. Is it yes or no? So that is only called
Yes, sir.
Newton's law of motion. If I will push the wall very forcefully, the wall also will push the same force with the same force. It will push me in the back direction. If I will push with less force, the wall also will push me with the less force. That is what you should remember. Do you understanding all of you? So this is what the Newton's law of motion. Do you understand, Ira? All
Yes,
of
sir.
you? So for example, let us take one more example for better understanding of this. Suppose let me take, understand. I can from this I can say that when one body influences another body by applying force, so we can say that means once one body, let us take two bodies, first body and second body. So when this body is trying to influence, means trying to apply the force on another body. Understand? So when this first body is interacting with the second body, what will happen, Ra? So when understanding any interaction between the two bodies, there is always two forces that come into play. Is it yes or no? If the two hands
Yes,
are
sir.
acting, means in the sense of this body is exerting some force on this body and this body is exerting force on this body. Is it yes or no?
Yes, sir.
Yes. So that's the part. Others also you have to respond. Mavanis, Darun, everybody. So Newton's third law of motion means, remember, Newton's third law of motion describes the relationship between the forces that come into play when the two bodies interact with one another. Interact with one another. That is
One
what.
another.
Suppose that this body is here, this body is here. Is it Newton's third law of motion? No. When the two bodies will come, interact each other. What is the meaning of interact? Interact means come
Sir,
contact.
touches.
Come contact each other. Come contact each other. Suppose imagine this is one body and this is another body. So if this body is trying to influence means trying to change of this position, understanding, by applying force, then this body is also exert the same amount of force on this body and it will also exert the same equal amount of force but in opposite direction. Opposite direction. Do you understanding, Ra? So this is only
Yes,
the
sir.
examples of Newton's third law of motion, which will illustrate the Newton's third law of motion. Understand? So you may understand very well. Correct, Ra? Everybody?
Yes, sir.
Yes. So that is what. So let us go with that. Now let us discuss more in detail. One more example. For example, you may observe. Let us imagine in our village, you may go to village. You people trying to pull the cow or bull sometimes. If you are taking into the agriculture land or somewhere, you may notice it. The people are trying to pull some cows will come very easily, but some cows cannot come very easily. We have to pull them like anything, like this picture. Have you noticed it?
Yes, sir.
So here you see. You may ask me the question, sir. Here the man and the somebody is speaking. The man and the bull is not come in contact, but here some interaction is there. Some interaction. Who is that? Who is that, Ra? Some interaction is there between them. So you observe very carefully here. The person is trying to apply the force in which direction, Ra? In this direction.
Left direction.
Is it yes or no? Let me imagine this is left side. Understand? So the person is trying to apply the force in this direction, but the bull is also exerting the same amount of force. In which direction? Towards the
Right.
right side. That is why the person is also will never move forward direction, and the bull is also will never come like this direction, because They both are applying equal and understand opposite forces. So you can see the person is trying to pull it like this and the bull is trying to pull it like this. But you may observe, sir, here there is no contact, there is no interaction between these two bodies. But here we have some common interact between these two bodies. What is that called as?
Rope.
Rope. Understand? So without that rope, is it possible to pull this bull? Without that rope, is it possible to pull this rope? No,
No,
sir.
sir.
This is my bull. This is my hand. No connection. Is it? I will say like that. If I'll pull, is it possible to pull the bull forward?
No, sir.
So that
No,
is
sir.
So here we have some common interaction. Understanding? So the common interaction between this bull and the man is called as what? Rope. Understanding? So he is applying the force in this direction and the bull is applying the force in this direction. So the both the bodies are coming contact each other. Is it yes or no? Come
Yes, sir.
contact each
Yes, sir.
when they will come contact each other. You may observe here, this person is trying to pull this bull forward direction, means he's trying to influence this bull. He's trying to influence this bull, and this bull is pulling him in the right side, means this bull is also trying to influence this man. So that is why we can say both are come contact each other. So here some law will come into play. What is that law called as? Third law.
Newton's third law.
Law of motion.
Law of motion. So Newton's third law of motion will come into play only when the two bodies understanding is come contact each other, and each understanding first body is trying to influence second body, then second body is also exert the same amount of force on first body, but in opposite direction. So that is why we can say always the Newton's third law of motion will give the relation between what will give Newton's third law of motion will give the relation. Understand, it will describes the relationship between forces that come into play when the two bodies interact with one another. Do you understanding, Ra?
Sir.
Yes.
Right. Very, very write it. Newton's third law of motion. Newton's third law of motion will describe the relation. Newton's third law of motion. Newton's third law of motion describes the relationship between. Describes the relationship between. Describes the relationship between two bodies. Relationship between the forces that come into play. The forces that come into play between the forces. The forces that come into play. Come into play when two bodies. When two bodies what? Two bodies interact with one another. Contact or interact. Interact with one another. Note it down. Is it completed? So this is what. So now, what Newton's third law will say, that is what we should learn. Definition. Definition. From this, can you able to say definition? Anybody? Definition. According to the Newton's third law of motion. According to the Newton's third law. What it will say, Pradosh? Darun, Elmukil, anybody? Thank you. Tell me. What it will say?
Every action has equal reaction.
Every action has equal and opposite reaction. That is what. Write it. Pradosh wants to write it, all of you. Every action has So from this I can say, according to the Newton's law of motion, whenever one body exerts a force of another body, force on another body, the second body is also exert an equal and opposite force on the first body. Do you understanding, Ra? Yes or no?
Yes, sir.
What the Newton's law of
Sir.
motion? What will says that whenever one body exerts a force on another body, write it. According to the Newton's law of motion, whenever one body exerts a force on another body, one body exerts a force on another body, one body exerts a force on another body, then what will happen, Ra? Another body, what will happen? The second body exerts an equal and opposite force. The second body exerts an equal and opposite force. Equal and opposite force on first body. Is it yes or no, Ra? So that is what we should.
Yes, sir.
All of you should remember. Okay? Yeah, another in the opposite direction. That is what you should remember. Understand? An equal and opposite force on the first body. Do you understanding, all of you? Now,
Yes, sir.
so let us imagine. So if you are understanding the Newton's third law, how many bodies are coming contact? Always. How
Two
many
bodies.
are coming contact? So two bodies. So understanding. So this is the body one. Understand? So this is called as what? Body two. Now, when they will come each other, understanding, when they will come interact each other. So let me imagine this is the body one, this is the body two. So the first body will exert some force on the second body. Is it yes or no?
Yes, sir.
Yes or no? We can
Yes,
write
sir.
issues. So you can see the first body exerting some force on the second body, and then if it is happening, what is happening? Second body is also exert the same and equal amount of force in opposite direction. That is what we used to call as third law. Is it yes or no? Now,
Yes,
remember,
sir.
first body, this is called as first body and this is called as second body. So the force exerted by the first body, understanding, on the second body, which we used to call as action. What we should call?
Action.
Now, once the first body exert the force on second body is also exert a force, equal force in opposite direction, then that is only we used to call as, understanding, force exerted by a second body on first body is only called as reaction. What we should call?
Reaction.
Reaction. All of you should remember. Understanding, all of you? Any doubt? Anybody? Please ask me. Yes, that is. So the force exerted by the first body and the second body is known as action. Like same way, the force exerted by the second body and the first body is known as reaction. All of you should note it down. The force, first one, the force exerted by first body on second one. First body on second body. Second body is called action. What we should call? Action. Monish, Tarun, are you understanding? Means the force exerted by this first body exerting on the second body is called as action. Understand? So now, oppositely, if second body will exert, the force exerted by, tell me, exerted by second body on first body. Second body on first body. What we should call, Ra? Is called
Reaction.
reaction. Do you understand?
Reaction.
But both are equal. Is it yes or no? So from this I can make some conclusion that every action, understand? If there is action, then definitely oppositely who will be there, Ra?
There will be a reaction.
Opposite reaction.
Will be there, but that reaction, it is opposite side, opposite to the action side. That is why I can represent with minus sign. Do you understanding, Ra? All of you. So this minus indicating what? Opposite to the action. Understanding? Opposite to the direction of action. You understanding, all of you? Direction of.
Yes, sir.
So that is what. So if there is action, then there is an equal reaction. Is it yes or no? So from this I can say Newton's law of motion means, so every action there is an equal and opposite reaction. Is it yes or no? Yes or no?
Yes, sir.
So brothers, you want definition, you note it down. This is what the definition. All of you note it down the definition first. So that is what. So from this I can say what I can say. So to every action there is an equivalent. To every action there is an equivalent.
Opposite reaction.
Opposite
Yes.
reaction. Understand, Darun? So that is what the statement is, should write it. Brothers completed. So you have to write now. To every action there is an equivalent. To every action there is an equivalent.
Opposite reaction.
Opposite reaction.
Write the statement. To every action. To every action there is an equivalent. Equivalent.
Opposite reaction.
Understand? So bottom you can write action is equals to minus reaction. Action is equals to, you can write what? Action is equals to
Minus reaction.
Understand? So action means what? The force exerted by first body on second body. Understand? First body on second body. So what is the reaction? The force exerted by second body or first body. That is what. Do you understanding, Ra?
First body.
That is. So this is what we used to call as action and reaction. Any doubt, anybody, please ask. Clear? Any doubt? Clear? Darun, Elamukil, Tamil Selvan? Anybody?
No, sir.
You ask. So this is what we should call as Manya, Laksha, Samya. Do you clear? Okay.
Sir.
Now let us discuss all of you. Observe very carefully. Now I will show you one diagram so that you may understand more clearly. Suppose let us take the two spring balance. Do you know spring balances, please? Do you know spring
Yes, sir.
balance? Yes. Now
Yes.
let us discuss that example so that you may understand more even clearly. So, for example, let me consider two spring balance. I will take it. So in this picture you may observe, I am taking the two spring balance. What is that? So let me take the spring balance A. This is the spring balance A and this is the spring balance B. Now you observe very carefully. So spring balance spring balance B, one end is attached to the wall hook. Is it yes or no? A wall and a hook.
Sir.
Have you noticed it? And middle, their hooks are tied each other. The two hooks are locked each other or tied each other. You may observe carefully now. So another end of this spring balance A, with my finger, I am exerting some amount of force. Understanding some amount of force. You may observe how much amount of force I am exerting here.
4 Newton.
Correct? So that the spring will expand 4 newtons. So if I am exerting the 4 Newton force on here, means this is called as action. I am trying to pull like this, action. Then you may observe here, in this spring balance B also, how much expanding spring? Same
4 Newton.
4 newtons. Means if I am trying to exert the 4 Newton force in this direction, then this one here the force is acting in opposite direction, same amount of force, but in opposite direction it is acting. Is it yes or no?
Yes, sir.
Yes. So suppose if I will increase the force into 5 newtons, then what will happen? Action direction. So here also what will happen? Here also it will increase to
5 Newton.
4 newtons, 5 newtons. So from this picture you may observe the force exerted by A on B, which is equals to what? Force exerted by A on B, which is equals to what? 4
Zero.
newtons. 4 newtons. Same way, the force exerted by B on A, which is equals to also what? 4 newtons.
4 Newton.
Opposite direction. So that is what you can see. Both you can coincide. So 4 newtons. Every action is equals to action equals to minus reaction. Action is equals to minus reaction.
Minus reaction.
This is what? 4 newtons. And this is what? Minus 4.
Minus 4 Newton.
So this minus indicating what? Minus indicating what?
Opposite.
Opposite
Opposite.
direction to the
Opposite direction.
understanding. Opposite direction to the action. That is what you should remember. Do you understanding that? All of you?
Yes, sir.
Yes. So this is what we can say. Force is equals to every action. There is an equal and opposite reaction. So this is what we can conclude it. Will you understanding or not? Any doubt? Anybody? You ask me. So from that experiment, we can say the force acting on body A. Understand? Sorry, body B on by body A is equals to how much, Ra? Which is equals to how much?
4 Newton.
4 Newton.
So the force exerted by body A on body B is 4 newtons. The same way, the force exerted by body B on body A, which is also equals to how much? Say
4 Newton.
minus
4
Newton.
Newton.
this is only we can say it is called as Newton's
Third law.
third law. Do you understand?
Of
Understanding all of you?
Yes, sir.
Yes or no? So that at this beginning of this chapter, we have studied understanding action and reaction, which is action to different bodies. Is it yes or no?
yes, sir.